Okay, so what today's webinar is going to be on is homocysteine, and this is a very critical marker. This is a pretty advanced workshop. So the good news about these my 𝗨𝗪𝘗𝗁𝘁 University is you can go read back and listen to this as many times as you feel that you need to, and that's really why I developed this online university. So let's just kind of go over what is homocysteine. Basically, homocysteine is really just an amino acid here. That's pretty much the whole gist of it. And one of the things I want to bring your attention to is if you have high homocysteine, what this can do is it can actually damage the interior endothelial lining right there. So that's what's so dangerous about it. That's one of the things that's so dangerous about it among many things here. So it can actually damage the interior arterial lining or the endothelium. So if you have high homocysteine, that can cause dementia. It can cause pregnancy complications, poor concentration, cardiovascular disease, osteoporosis, and diabetes, among many other things. So what this picture is here is of the artery. So what you're going to be really seeing here is your artery here is one cell thick, right? You can see that it's only sitting at one cell right here, right? Okay, so what happens is when you have high homocysteine, if you look over here, it's actually damaging that one cell thick. And what happens is when that's damaged, all the things in your blood, this would be your blood right in here, right? And the green line right there, that's your blood. What happens here is when you have high homocysteine, it damages the lining right here, which is the endothelial lining, and things in your blood leak out into your tissues, into your organs. And what you see right here is that little purple thing here and this little white thing right here. Those are your immune system. Right, so that's your immune system. So if you can imagine, your immune system is leaking out into your tissues, because all your tissues are right in here. This is where all your tissues are. I'm just going to put a T here, tissues. So if you have this leaky gut, your immune system actually goes ahead and attacks those tissues in your body, and obviously that's not optimal, right? So homocysteine, in my opinion, is a very important marker that we want to measure and make sure that we're actually monitoring that, and we're actually able to decrease your homocysteine. So if you have your blood work, you want to pull out your blood work, you're going to see homocysteine right there. If yours is high, it's going to be in blue. This lady is 19.4. Now you can see here lab range, we want this less than 10.4. So that's the lab range. Now, if you've watched any of my other videos, we talk about functional range. So a functional range, we want this between 5 and 8. So you can see this person right here is sitting at 19. We want it between 5 and 8. So that's a major problem. He has major inflammation, brain fog, autoimmune conditions. You have to decrease your homocysteine. Homocysteine is not a very pleasant marker to have elevated. Now, these are some of my patients. I just like to kind of throw this in, and right here you can see when these were taken, and then you can see the level here. This level started at 18.2, and you can see over time what's happened with this person's homocysteine. It's kind of fluctuated, so we need to start putting more attention on it, because that's definitely it's starting to creep up. So this is another one of my patients. This was pretty amazing. I was actually shocked. You can see the dates down here. Basically, it's literally about about 40 days. She went from 23 to 9. So this is an amazing drop when it comes to homocysteine. Here's a few more markers that we have. This person came in on functional medicine. I actually really didn't start addressing homocysteine until right there. We were doing a bunch of other things that we were trying to handle. But as soon as I started putting attention on it, you can see how it dropped from the lowest, which was at one time right here. This is 16, and then it dropped down to 11.3. So we have a ways to go, but we're getting there. This next case, next case here is a really interesting case actually. This is a male that came in to me, and he was actually in the hospital for like 14 days for an infection in his leg. Like they thought that they were actually going to have to cut his leg off. So if you're in the hospital for 14 days, you know that you have a very, very severe problem if you're in the hospital for 14 days. So you can see that his homocysteine, again down here, started off at 19, and then we checked it basically, about 2 months later. It went down to 13.9 and then 13.0. His vitamin D was in the tank too. So he's done a whole functional medicine program, but his life is completely different in a matter of 3 months doing functional medicine. He had like skin lesions, and his skin would get itchy and it'd break out, and digestive problems. I mean, the guy was just a mess, and we pretty much he's gotten his life back through functional medicine. So these next couple slides here, what I'm going to go over is actually what the research shows about elevated homocysteine, in particular brain function. So you can see here, they measured homocysteine. Anything above 13.8 is considered in this lab is the highest. So what we're going to be talking about here is brain infarction. So what that means is basically where your brain is dying. This comes from the literature, and what it says here is the research is showing that if you have homocysteine in this particular study greater than 13.8, you have your risk of a silent brain infarction, which is basically when your brain is dying, is 2.5 times greater than someone that would have a normal homocysteine. Or severe white matter lesion, you have an increased risk of 2.3 times greater risk of lesions. Now you can look at this person's brain right there. That's the white lesion matter. That's actually the brain dying. Right? So I just want to state that again. That's actually the brain that's literally dying because of homocysteine affects the brain and causes in that first picture that I showed you. Let me just zoom back to that. In this first picture right here, you can see what I'm saying here is this stuff right here that leaks out, right? If you have this artery being leaky, things can leak out into the brain. It leaks out into the brain and causes death to your brain and all your tissues. So homocysteine is actually ruining the artery there, the lining, and it's only 1 cell thick. So that's what's happening when we talk about your brain here. Is these white lesions are actually those white lesions are actually brain tissue that's actually being literally dying because of high homocysteine levels. Here's another study. They showed this here. This is a big study. It's the same study. Basically, 1,000 people aged 60 to 90, and if you can just read this sentence, kind of right in here, and I'll just read this here for you. The overall risk of having either a silent infarct or severe white matter lesion was strongly associated with a total what? With a total homocysteine level that in this case is greater than that, what was it, 13.9 or something like that. So again, down in here, this is what we're looking at. This is where your brain is literally starting to die and degenerate. Here's another picture. Looks a little bit better. I think you can see this. This is normal, healthy, white matter tissue. That's the way you want your brain to look. And then you can see right in here. You can see right in here the brain is actually starting to degenerate, and homocysteine levels, elevated homocysteine levels, cause this to occur in your brain. Now, why is that? So I just want to point out a few things here, which I think are pretty important. So you can see here, that right there is the artery, that little blue line. These are all these little arteries right there that go deep into your tissue in your brain. Now, This could be your brain, but this is any organ in your entire body, right? So the study was on the brain, but this is on any organ in your body. Now, I want to bring your attention to this. It says deep micro bleeds. So again, remember that first picture where I showed you that artery was being torn apart, and then what happens is when it tears things apart, your immune system leaks into your brain, right? If it leaks into your brain, it's going to start to attack and damage the things in your brain. It's going to cause brain lesions, brain fog, Alzheimer's disease. All these things just get worse and worse and worse. And up in here, you can see there's another picture of it. You can see the artery, and then you can see these little, these little like blue areas there. That's where the brain lesion is starting to attack. It's starting to get worse. This is a good area right in there. So this is literally homocysteine. Not only is a chronic inflammation, you can just assume that if you have high homocysteine, your body is chronically inflamed, and we need to decrease your body's inflammation. This is just a follow-up on that same study. This is kind of technical, but basically, if you wanted to read the technical aspect of it, basically, it's just basically saying that if you have high homocysteine levels, I'll just highlight this area here. High homocysteine levels are a marked increase for cerebral microangiopathy. So what's that big word down there? And I kind of put the definition down right in here. You can see that. So what that is basically it's just telling you that you have affected your small blood vessels are affected in your body, and that causes disease of your blood vessels. So in other words, just kind of like what I showed you in that first picture, your arteries are diseased, they're leaking your white blood cells out into your organ tissues, and that is causing an autoimmune reaction. I like this kind of graph here. It just kind of shows again the artery here. You can see this is 1 cell thick, right? So it's really, let me just change the color, see if there's a better color. You can see it's just 1 cell thick here. So that might be a little better. So you can see it's just 1 cell thick. So if there's damage in here, right? If there's damage in that area right there, that's going to cause problems. So that 1 cell thick, right? 1 cell thick, and like look at how this one blood cell, how small that is, right? So we're talking, here's a vasoconstriction, means your artery's gotten tighter, and now tissue can't go through there, or I should say blood cells can't go through there, and right in here we have, that's where it's irritated, it's damaged there, and things would start to, literally leak out right into your organs, and your organs sit right down in there. So a lot of stuff happening with that. Now here's really an interesting, how powerful the things that we're doing here, and I'm just going to kind of read this right here. It says, we speculate therefore that progression of vascular dementia, and there's a lot of dementia, Parkinson's, Alzheimer's disease, just brain fog, forgetting things, in patients with identified hyperhomocysteinemia. So again, they're saying 13.9, but what I'm saying is, anything above greater than 8 here is a problem functionally. Could be prevented by, I love this here, could be prevented by what? Vitamin supplementation. So this is a key thing with that. Now, if you've been on my website here, I'm going to go into a little bit of DNA, because homocysteine is a really critical marker for DNA production. But I do a whole hour on this DNA thing. So if you really want to get all the skinny on this next part, you can watch that video. I'm going to try and wrap what I did up here in a matter of like 10 minutes or so. Okay, so you can see down here we have homocysteine, right? Now we want that marker to be between 5 and 8. So this is what we call the methylation cycle. Now it's a big term. I don't want to get all into this really in depth. That would be for the DNA video. But what I just want to show you is, you see this right here, this MTHFR, and then we have the MTR, and then we have the MTRR. So all these things work like a clock, right? So what I mean by a clock is, this is what I mean by a clock right here. So you can see all these different components right here of the wheels, right? So we got one wheel here, and then we have another wheel here, and then we have another wheel here. So they're all turning together, right? They're all turning together to make the clock work correctly. Now let me just kind of get back to this. Let me remove that. So what I mean by that is, this area right in here, these are your genes. So genes produce certain things. Now functional medicine, we can actually go in and test these genes to see if you have a sluggish gene. So what I mean by this, if you have a sluggish gene, these things right here are really not turning correctly. So let me just use this analogy right here. Again, getting back to this clock here, this right here would be one gene, this is another gene, this is another gene right there. So they all spin together, they all work together. Now just imagine if a grain of sand gets like right in there. Okay, so we have a grain of sand that's getting right in there, and when you have this grain of sand, what's going to happen is it's going to prevent, let me just clear this out. So we have a grain of sand right here, right? So what happens is that's going to prevent the normal twisting and cycling of this clock. Okay, so I'm just trying to make an analogy here. All these little wheels work together. So let's get back to your body here. So if you have things down here, if these genes aren't working correctly, and you can measure this to see if you have any sluggish genes, but you're going to see down here, you're going to see this homocysteine down here. You see that? Now these things kind of work together. Like here's one wheel, here's would be another wheel. Okay, let me just clear this out. So here's one wheel, and this wheel comes around here, and then we have another wheel coming around here, and then we have another wheel coming around here. So my point is, if we have a sand of, if we have a piece of sand at this gene, that's a gene, this gene, this gene, you can see how homocysteine is going to start to build up, because this whole cycle here, really what this is doing is it's recycling and it's getting rid of homocysteine right here. So if you have a high homocysteine, that's telling you that your genes probably are not working very well. Now what we're trying to do is, what this cycle does is it puts this, what we call methyl group, onto the DNA. So if you have homocysteine, you can just assume this little yellow marker is not being placed on your DNA. So your DNA would be not very healthy. So this is really critical. So when we talk about functional medicine, we're actually getting into the nitty-gritty of actually working with your DNA. If you have high homocysteine, I guarantee you that this little methyl group right there is not getting onto your DNA. And this is really, really critical for healthy DNA, that this methyl group gets on here. Now, what these little genes do here is they just pass this little methyl group to the DNA strand itself. But again, if you have a little grain of salt in these little genes, they don't spin as quickly, and then what happens to your homocysteine? It goes what? It starts to elevate. Now what they've done, and I go over this really in depth in my DNA workshop, is what they've done is they've taken mice. Okay, so you can see right here this little that little green area right there. Okay, you see that? That's the methyl group. Okay, let me just kind of scoot back here. That's this part right here. Okay, so you can see this part is being placed on the DNA. Okay, so let's kind of scoot back here. So you can see this right here, that's this little methyl group, and this right here, that little strand, that's the DNA. All right. So, or you can, I put a better picture of it right here. That right there, that's this methyl group on the DNA right there. Okay. So this was an amazing study. So what they've done here is they've taken, what they did is they had two different moms. Now, through genetics, right, through these mice genetics, these mice are exactly the same. So what I mean, they have two mommies, right? And the two mommies are identical. DNA are identical. And then what they've done is then they made each of these mommy mice pregnant. And they used the same genetics, in this fertilization kind of thing. So the mommy mice are identical, and the baby mice in mommy's stomach are identical. All right, so they're identical, genetically the same, even though they have two different mommies. They're identically the same through, that's how advanced science it is. Now, what I want to show you here is this thin mouse here. You can see that. Let me just read this statement down here. The only difference was the brown mouse was fed food that contained what? These methyl groups. Okay, now at the end of the video, I'm going to show you where you find these methyl groups. So what they found is when the mom, so this mom right here, in the food that they gave that mom had methyl groups. And it was thinner, it had less cancer, it was healthier, the coat was actually brown. Okay, so then what they did, then they had here, they had the same mouse, but they didn't feed the mom. So we're talking, these are the offspring now. They didn't feed the mom any methyl groups in her food. So you can see down here, so you can see these methyl groups right here. You see none of these methyl groups are there. So none of these here are on that DNA. You see that? Now what happened to the mouse? It had a yellow coat. It was prone to diabetes and cancer. So what is that telling you? That's telling you that the food that you eat influences your DNA. Now, if you have high homocysteine on labs, guess what this tells us? This tells us that these little methyl groups are not getting on your DNA. That's what that's telling us, right? So let's kind of move back here. So if you have high homocysteine, this tells us that this little marker is not getting on your DNA, and your DNA is not healthy. That's what we can tell by homocysteine being elevated, meaning that you have a little grain of grain of sand in these genes, slowing this pathway up to get rid of homocysteine. Because you can see here, if this is working normally, right, like here and then here, homocysteine would be recycled, and you would have low homocysteine. What happens though, if this, let's say just this gene right here has a little grain of sand in it, homocysteine is going to hit here, and this is going to be slow. It's going to slow this down, and that's going to build up homocysteine. So if we build up homocysteine, then this methyl group is not getting put on your DNA. I know this is complex. You're going to want to go back and listen to this video multiple times. That's the good news. You can listen to this video multiple times and get this down. So getting back to this mice here, what it's telling you is we need to make sure that your diet has a lot of these methyl groups, because if you do, you have good DNA, and it decreases your risk of cancer and diabetes and depression. I mean, it goes on and on and on these things here. Okay, so again here, this is just the homocysteine. You see homocysteine right here. Now, what we can do is we can actually support your body. So we can actually support these genes and give your body what it needs, which is what? Which are these methyl groups. So just look at these vitamins right here. So you can see here, this is methyl. Okay, that's a methyl group, right? So that's what we're giving you, a methyl group right there through supplementation. I put a lot of people on this Homocystex Plus. So there's a methyl group. There's a methyl group. And you can see here, here's another methyl group. So within this one supplement, this is, these are B vitamins and mixed in with some other things, there's multiple methyl groups. Because why we want to do that is if you have, a pebble here, a grain of sand in there, it doesn't spin, so homocysteine builds up. So if we support your body with these methyl groups, okay, then we can force this thing to spin. Even if you have a sluggish gene or a grain of salt in your a grain of sand in your salt, we can still force these things to spin right? And then when we do that, guess what happens to your homocysteine? It's going to go down. It drops. Now let's just go to, some people will go and get some vitamins somewhere else. Now you can see this here, this is a GNC vitamin. You can see this is a GNC vitamin. Now what you want to see here is you can see this here, cyno, this is a B12, 𝗨𝗪𝗶𝗵. Now if you know anything, cyno is cyanide, meaning that's the stuff that they give rat poison, right? They give cyanide to rats to kill them. So this is what you take. If you get cheap vitamins, you get 𝗨𝗪𝗶𝗵, which is this B12 right here, okay? You can see this is the B12. So now look at the vitamins down here that I'm actually recommending people take here. Now you can see here, these are the methyl, right? So down here you can see, this is maybe a better one right here. You can see that it says 𝗪𝗶𝗶𝗵. So what we're doing is, this is really cheap to produce right here. This is cheap to produce. Cyanide is cheap. What costs money is actually sticking on this methyl group onto the B12. But we're supporting your body with this product here, with 1, 2, 3 methyl groups. All right. So just the strategy when it comes to functional medicine here is very, very specific to try and reduce your body's homocysteine. Okay, so these are just 12 tips that you can do to increase your your B12 status. B12 is found in leafy green vegetables, right? Get more B vitamins, B6, B12, and you want to make sure they have what? The methyl groups, right? They have to have the methyl groups on them. Okay, minimize sugar, conventional raised beef. And these are all basic sense things. These are all going to help someone decrease the homocysteine. Caffeine, alcohol, smoking, medications. You want to avoid all those things. Here's some really key things. You got to have good, healthy gut bacteria. You got to have good gut BMs. Regular BMs are 2 to 3 bowel movements every single day. They're very consistent. You don't have any gas, bloating, diarrhea, irritation. You don't take any stomach medications at all. You want to improve your HCl in your stomach, so there's some HCl challenges that we can do. You want to use a lot of methyl support donors, which I do, which I kind of showed you. Magnesium and zinc, they all support this mechanism here. Just these are a lot of B6, B12, betaine. That's helps your body break down food. So anyway, this is the end of the homocysteine webinar. I hope you found value in it and that you can see how critical homocysteine is in you actually getting well and staying well.